So today we are going to be continuing our notes on periodic trends. For this lesson, we are going to be covering reactivity. Now, for this, you do need to make sure you've got your notes. You need to make sure you've got something to write with, and then you will also need a periodic table. Okay, so let's take a look at reactivity, this trend that we have on our periodic table. So what is reactivity? Well, reactivity is basically how likely something is to form a bond with something else, how likely it is to gain or lose electrons. Now, I say gain or lose because that depends. If I'm talking about a metal, metals do one thing, nonmetals do another. So metals, it is how likely they are to lose an electron. Okay, so the trend for this, really for reactivity for a metal, is ionization energy. The lower your ionization energy, the more likely the metal is to react, which means it is going to be more reactive. Okay. Now, for nonmetals, we use something called high electron affinity. Now, that's actually a trend that we're not going to teach you, but electron affinity is essentially how likely they are to attract or gain electrons. Okay, so we know that nonmetals tend to gain electrons. And so for this, really what you're looking at with nonmetals is you're looking at the greater ionization energy will make it more reactive. Okay, so what is our trend? Well, for metals, the vertical trend is that as we move down the periodic table, we're going to become much more reactive. Why? Because we're going to have a greater number of energy levels, okay? And in comparison to our protons, that's not going to be enough to offset that difference, right? And so we're going to have a greater number of energy levels, which means those electrons are really far away from the nucleus. So there's going to be less attraction to that nucleus. And so it's going to be very easy to take an electron away. So the further we are towards the bottom of the periodic table, the more reactive a metal will be, okay? The horizontal trend is the further we are to the left side of the periodic table, the more reactive we will be. Why? Because we're going to have fewer protons in comparison to all the others, so further to the right side. So if I'm looking for for my vertical trend, again, remember the further you are down towards the bottom with the metal, the more reactive it is. For the horizontal trend, the further you are to the left side of the periodic table, the more reactive it is. Okay? All right. So what I want you to do is just summarize both of those trends in your own words. So pause your video, summarize the trend, and then we'll go over it. All right? Okay, so here is our trend for metals in terms of reactivity. Essentially, as you move down the periodic table, it is going to have greater reactivity. And as you move left on the periodic table, it is going to have greater reactivity. Okay, that is going to be your trend for metals. So if I'm going to be comparing calcium and barium, which one would be more reactive? Well, both of those are actually on the same family, right? They're both alkaline earth metals. So looking at this, I'm comparing how the vertical trend. Calcium is on the 4th energy level, whereas barium is on the 6th. We know that metals get more reactive as we move down the periodic table. Since barium is closest to the bottom, it's going to have a greater reactivity. Okay, so barium would be the more active metal. Again, why? You would have a greater number of energy levels, which means you would have more distance from the nucleus to the valence electrons. Okay. All right, now let's look at our nonmetals. So for nonmetals, essentially it's going to be the opposite of our metals. Okay. So for nonmetals, what we're looking at is as we move down the periodic table, we're going to get less reactive as a nonmetal. Now, why would that be? Well, as we move down the periodic table, we're getting more energy levels, right? So it's getting larger and larger and larger. Well, remember, for nonmetals, their reactivity is based off of how likely they are to attract an electron. So if it's really far away, if that electron is really far away from my nucleus, it's going to be much harder to attract an electron than if it's really close to the nucleus, right? So for Nonmetals, the vertical trend is as you move up the periodic table, you become more reactive. Okay? For the horizontal trend, let's talk about that. As I move across the periodic table, what am I going to be changing? I'm going to change my number of protons, that effective nuclear charge, right? And so if I go from left to right on the periodic table, I'm going to have more protons, which means I'm going to have more pull, more nuclear charge, which means I have a greater amount of Zeph, so it's going to be more reactive. Okay, so as I move right across the periodic table, it becomes more reactive. Okay, so I want y'all to summarize that trend in your own words. All right. So your trend is as you move up the periodic table, it becomes more reactive. And as you move right across the periodic table, it becomes more reactive. Okay. And so if you notice, your trend between your metals and your nonmetals is actually opposite of one another. Why? Because metals are going to be trying to lose electrons, so the further away and fewer protons are going to be more reactive. And nonmetals are trying to gain electrons, so the smaller the atom and more protons, the more reactive. Okay, so if I'm comparing phosphorus and chlorine, okay, I've got phosphorus, which is number 15 on the periodic table, and then I've got chlorine, which is number 17 on the periodic table. They're in the same energy level, right? So now we're going to be comparing our number of protons. Well, since chlorine has more protons, remember with nonmetals, it's trying to gain electrons, so you want more protons to gain those electrons. So what that tells me is that chlorine is going to be a more reactive nonmetal. All right. Okay. Well, the rest of this is going to be practice for y'all. Now, this is kind of a general table for y'all. It's basically just a generalized way for y'all to look at this. Group 1, which remember is your alkali metals, they are going to be very, very reactive. Why? Because they don't have many protons in comparison to everything else. Group 2 is still going to be reactive, but less reactive than Group 1. Groups 3 through 12, those are all your transition metals, right? Well, your transition metals actually have very low reactivity. Why? Because they've got a greater number of protons, but they're still trying to lose those electrons since they are metals. Group 17, so we did skip a few there, but group 17 is going to be trying to gain electrons, and since they have a very large amount of protons, they're going to become more reactive. Okay. And those will be called our our halogens. And last is group 18. Group 18, which is our halogens, are actually inert. Now remember, inert means they are non-reactive. Well, what does non-reactive mean? Why would they be non-reactive? Well, non-reactive again would mean it doesn't react, right? But why? Well, they wouldn't be reactive because they're nonmetals, right? And nonmetals tend to gain electrons. But if you think about your noble gases, they've already got a full valence shell. So if they gain an electron, they become less stable than they were before. Okay. And so since they're less stable, that's not going to happen because chemical bonds form because it makes things more stable. All right. So I'm going to leave the rest of this for practice for y'all. I do suggest that y'all go in and fill out this table with an explanation. It'll be on the key as well. But otherwise, y'all have a great rest of the day and let us know if y'all need anything. Bye, y'all.